Welcome, I'm Aparna Tagare. In this presentation, we are going to study measurement of secular trend by method of least squares. Measurement of secular trend by method of least squares. We take into consideration the following points. In a linear trend, the trend equation is given by xt is equal to a plus bt. Here t represents time and this xt represents the variable like production, sales, demand, like that. So it is similar to linear equation we have already studied, y is equal to mx plus c. It is similar to that equation. Instead of that y, here we have xt, and instead of that x, here we have t. Okay, so it is linear equation and we are using these variables xt and t for time and xt is for the variable we are considering, like production, sales, and like that. We solve the following set of linear equations known as normal equations. Now when we want to write equation of trend line, here these two are variables. We know time, we know values of the variables using that time series data. There are these two values a and b. Okay, to we have to write this equation, we require values of these two a and b, these two unknowns. To get values of these two unknowns, we require two equations in these two unknowns, and these two equations are these equation number 1 and 2. Solving these two equations, we find the values of a and b, and substituting those values here in place of a and b, we get the equation of trend line. Now these equations are summation xt is equal to na plus b into summation t. It is first equation. And second equation, summation t xt is equal to a into summation t plus b into summation t square. Now here in these two equations, if we have data or observations from that time series, we can find summation t, we can find summation xt, we can find summation t xt. Here summation t we can find, and again we can find summation t square. Using the given data, we substitute those values here, and solving these two equations, we can find values of a and b, and substituting those values here in place of a and b, we get equation of trend line, where n is the number of time periods for which the data is available, and summation xt, summation t xt, summation t, and summation t square are obtained from the data. Okay, so n is number of observations. If we have observations of 10 years, then n is 10. If we have observations of 9 years, then n is equal to 9. Okay, solving equations 1 and 2, we find values of a and b. The required equation of trend line is obtained by substituting values of a and b in this equation. xt is equal to a plus bt. Now consider this example. The following table shows production in 1000 tons of a commodity during years 2011 to 2019. Okay, now here years are given, that is these are values of this variable t. T is equal to 2011, 2012, 2013, and so on. And xt, this xt is for production, and production is 60,000 tons, 35,000 tons, 40,000 tons, and so on. Now we have to get the trend line equation, we require values of a and b, but if we observe these values of t, these are 2011, 2012, and so on. So while solving examples, trend line is represented by, now instead of this xt, we denote it by yt. Yt is equal to a plus bt. This year we denote by t, and this production, here in this case it is production, it may be sales, demand, and so on. This variable we denote by yt. It is equal to a plus bt. Calculations are made simpler by transforming t to u. Now if we observe values of t, these are 2011, 2012, 2013 and so on. So to make calculations simpler, we transfer t to u using this formula. U is equal to t minus middle t value upon h if n is odd, and h is the difference between successive t values. Now if we observe values of t to 2011, 2012, 13, 14 and so on. Now difference between 2011 and 12 is 1. 2012 and 13 is 1. That is, h is difference between successive t values. Here h is 1. Now n is odd. In this presentation we are going to discuss the example where n is odd. N is number of observations: 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of observations are 9. Here n is odd. In this presentation we are going to solve example where n is odd. In next presentation we will solve the example where n is even, but here we are considering the example where n is odd. So here number of observations are odd, 9. Okay, so we transform this t to a new variable u. U is equal to t minus middle t value upon h. Here h is 1. Now middle t value, total number of observations are 9. Therefore fifth observation will be middle observation. 1, 2, 3, 4. This fifth, and 1, 2, 3, 4. So middle observation is 2015. So middle t value is 2015. So here this middle t value we substitute 2015 and we take h as 1, and instead of t now we use u. Okay, so it is used to make to make the calculations more simple. Okay, so it is I have taken this only for example. We will discuss it in our next example. Okay, now if you have to remember all the things in this page very carefully, because these are the things we are going to use in actual solving the example. If n is odd, u is equal to t minus middle t value upon h if n is odd and h is difference between successive t values. Second point to remember, the equation of trend line becomes, now instead of x we are using this variable yt. Yt is equal to a dash plus b dash u. Now instead of t, here we are going to use variable u. This u is here instead of t. Now instead of a and b, we are only making them as a dash and b dash. We want to find values of a dash and b dash. And here yt, the other variable, here u is for time and yt is the given variable, either production, sales, demand and so on. The two normal equations are given by summation yt is equal to n a dash plus b dash into summation u, and second equation summation u yt is equal to a dash into summation u plus b dash into summation u square, equation number 2. Now here we want to write this equation, and in this equation a dash and b dash are unknown. To find values of these two unknowns we require two equations. In these two unknowns, here a dash b dash, a dash b dash, so these are the two equations. Solving these two equations we find values of a dash and b dash and substitute them in this equation, and we get the equation of the trend line. We have to find equation of trend line. Okay, so from given data, here n is number of observations, we can find all the values other than a dash and b dash using given data. Only we have to substitute them in this equation and solve them. Okay, so now we see how to solve examples. First example, the following data gives the production of bleaching powder in 1000 tons for the years 1962 to 1972. Okay. So here values of T are given: 1962, 1963, 1964 and so on up to 1972. And other is production. 0 tons, 0 tons, 1000 ton, 1000 ton, 4000 ton and so on up to this. Okay, so here these are values of t, and these are values of yt or xt. In our explanation we are using variable y. Okay, so these are values of yt. Use the method of least squares to fit a trend line. Also obtain the trend value for the year 1975. Now we have to use these values, and we have to use a method of least squares to fit a trend line. That means to fit a trend line, that means we have to find equation of trend line, and using that equation of trend line we have to find trend value for year 1975. Here we have data up to 1972, and using that equation of trend line we have to predict uh, value of production in year 1975. So first we find the trend line. Now if we observe, these are 1 2 3 4 5 6 7 8 9 10 11. So n is equal to 11, that is odd number of observations are there. In this presentation we are going to solve the example which is having odd number of observations, that is n is odd. Okay, so here n is equal to 11, n is odd. So we find middle value. Now if n is 11, middle value will be 6 value, 1 2 3 4 5, and this 1967, it is middle value of all these values for t. Okay, so the middle value of t is 1967. Here after 1967 there are 5 observations, before 1967 there are 5 observations, therefore 1967 is the middle value of the variable t. Okay, so h is equal to 1. Now the difference between two successive years, 1962 then 1963, so difference between these two is 1, then 63 64 65, the difference between each two successive years is 1, so h is equal to 1. Now we use the transformation from t to new variable u. U is equal to t minus middle t value upon h. Here middle t value is 1967 upon h is equal to 1. So we substitute these values in this formula. We get u is equal to t minus 1967 upon 1. So we get u is equal to t minus 1967. Okay. The equation of trend line becomes yt is equal to a dash plus b dash u. Now instead of t we are going to use this variable u, new variable u. Yt is equal to a dash plus b dash u. The two normal equations are then given by summation yt is equal to n into a dash plus b dash into summation u. Second equation, summation uyt is equal to a dash into summation u plus b dash into summation u square. Okay, and we have taken this middle value so that this summation u here and here, these values become 0 and the calculation becomes simple. Okay, we will see them. So to solve these two equations we have to find values of a dash and b dash. So other values, this summation yt, summation u square, summation uyt, we have to find from given data. So we obtained summation u square, summation yt and summation uyt from the following table by given data, and given data is of years t and production. Okay, so we make this table. This year t, these values are given 1962 up to 1972. Production, it is denoted by yt. These values are also given. So first two columns are given. Now we have defined new variable u. U is equal to t minus 1967. Here these are values of t. Only we have to subtract 1967 from this. So 1962 minus 1967 we get minus 5. 1963 minus 1967 we get minus 4. 1964 minus 1967 we get minus 3. Similarly, 1965 minus 1967 we get minus 2. Here 1966 minus 1967 we get minus 1. Here 1967 minus 1967 we get 0. And similarly, subtracting 1967 from these years, we get here 1 2 3 4 and 5. So we get these are values for new variable u. Here we get 0. Now here we require summation u square. Okay, so for here summation, here summation, here summation, and here summation. So where there is summation, we have to make column for those terms. Here summation yt is there, so here yt we have column for yt. Summation u is there, so next column is summation u. Addition of all the values will give summation u. Summation u square is there, so we have to make column for u square. So here column for u square, and adding all these values we get summation u square. Again here summation u yt is there, so we have to form column for u yt. Here the values for u and here values for yt, so taking their product u yt, so we make column for u yt, and addition of all this column will give summation u into yt. So here we get u, then u square minus 5 square 25 minus 4 square 16, 9 4. We square all the numbers in this column, we write them here, so we get column for u square. Then u yt, we take product of these two columns, entries in these two columns, minus 5 into 0 0, minus 4 into 0 0, minus 3 into 1 minus 3, and so on. We take this product and we get this value. Now these values summation yt we get here, addition of all the entries in this column, summation yt is 46. Summation u, now we have chosen the middle value 1967, so we get summation u equal to 0. This reduces our calculation, or this makes our calculation very easy. So we get summation u is equal to 0. Now summation u square, adding all these values we get summation u square 110. Then here we require summation u yt. Here adding all these values we get summation u yt is equal to 114. So here 1 2 3 4 we get all the values. Summation yt is 46, we substitute here. Summation u yt is equal to 114, we substitute here. N is equal to here, n is equal to 11. Now summation u is equal to 0, we substitute here. Here again summation u we substitute 0, and summation u square we have this value 110. Here we have found it, summation u square 1. So we substitute these values from this table in these two equations. Now there are only two unknowns, a dash and b dash. We solve these two equations and find values of a dash and b dash. Okay, so we substitute the values obtained from the table in the normal equations. So it is first equation, we substitute this value summation of yt from the table, n is equal to 11 and summation u equal to 0 in this equation. So we get 46 is equal to n is equal to 11 into a dash plus b dash into summation u is 0. So this second terms becomes 0. We can find value of a dash. A dash is equal to 46 upon 11. So 46 is equal to 11 a dash plus 0. So a dash is equal to 46 upon 11. It is equal to 4.1818. We get value of a dash. Now we have to find b dash. Second equation is this, summation u yt is equal to a dash into summation u plus b dash into summation u square. We substitute summation u square here, summation u equal to 0 here, and summation u yt here. Summation u yt from the table 114. Here a dash into this summation u is 0. So this term gets cancelled. Plus b dash into summation u square 110. Only we substitute these values from the table here. So here we can find value of b dash. B dash is equal to 114 upon this 110. So 114 is equal to b dash into 110. Therefore b dash is equal to 114 upon 110. It is equal to 1.0363. We get value of b dash. From that table we substitute values of these four things in this normal equations 1 and 2, and we get values of a dash and b dash. So the equation of the trend line yt is equal to a dash plus b dash u. Only we have to substitute these values of a dash and b dash here, and we get the required equation of trend line. Yt is equal to 4.1818, which is value of a dash. Here we have found it. B dash into u, value of b dash is 1.0363, 1.0363 into u. So we get this equation, which is equation of trend line, where u is equal to t minus 1967. Okay, so this equation yt is equal to 4.1818 plus 1.0363 into u is the equation of trend line. Okay, now trend values computed using this equation are given below. Now we have to find trend values. So only here in place of u we have to substitute value of u, where t is from our data. It is from 1962 to 1972. Only we have to substitute this value of t, calculate u, and substitute that value of u here, and we get required value of yt. Okay, that is production. So here values of t here from 1962, 63 up to 1972. Now how to calculate trend value? We have to substitute 1962 here. So 1962 minus 1967, it is minus 5. Therefore u is equal to minus 5, and we substitute minus 5 here and calculate yt. We get that yt is equal to minus 0.9997. Now to calculate trend value for 1963, here value of t is 1963. We substitute 1963 here. So 1963 minus 1967, we get minus 4. So u is equal to minus 4. We substitute here u is equal to minus 4, and the calculation gives yt is equal to 0.0366. So using this value of t here and substituting value of u here, we can calculate yt, that is trend value, that is production. Okay, so now we want to estimate or find trend value for the year 1975. So here 1975 is value of t. In that formula we have to substitute uh, t is equal to 1975 and calculate the production. Here t is equal to 1975, therefore u is equal to t minus 1967. So here in place of t we write 1975. So 1975 minus 1967, we get 8. So we get u is equal to 8. Only we have to substitute this value u is equal to 8 in the equation of the trend line. The equation of trend line is yt is equal to 4.1818 plus 1.0363 into u. In this place of u, we have to substitute 8. So we get this yt, that is production for the year 1975. So yt is equal to 4.1818 plus 1.0363. In place of u, we substitute 8. This calculation gives yt is equal to 4.1818 plus 8.2904. It is equal to 12.4722. Okay, so the production is yt, this value. So the trend value for the year 1975 is 12.4722 in 1000 tons. 12.4722 thousand tons will be production in 1975. So using this equation of trend line, we find the production in 1975, while the data up to 1972 was available. Okay, so the trend value for the year 1975 is 12.4722 in 1000 tons. Okay, so using this equation of trend line, we can estimate the future value. So here in this presentation we have solved example where n is odd. Okay, we in the next presentation we will see how to solve example where n is even. Thank you for watching.